Hi, I'm Meta Spencer. We're going to talk about rock dust because it's really, really important. And it's one of the things that can not only help us with our food shortage, so we need to use rock dust as a way of improving the soil and the quality of the food that we produce. But rock dust has another wonderful advantage, which is that it can capture CO2 out of the atmosphere and hang on to it indefinitely, like thousands or millions of years, if you know what you're doing. But that's a tall order. I wouldn't have a clue what to do if I were a farmer. So I've assembled some fine people here today who are going to give us some idea. I invite people who are experts, and then I have a whole bunch of Pugwash members who are smart folks, and they mainly question the experts and make sure we have looked at all angles of whatever it is we're examining, with the idea of establishing in our own minds whether or not we should ask the Canadian government to support and encourage and maybe even help fund the development of rock dust as a soil amendment. I have not previously met Gregory Dibble, who is a professor of earth sciences at the University of British Columbia. And Peter Van Straten is the professor emeritus of environmental science at the University of Guelph. Thomas Vanagore, I've already met before. Thomas is in Vermont. He is a big specialist on rock dust farming. He knows more about it than most of us, at least. And he is the owner of at least one quarry, I think several quarries in Vermont. We have several Pugwashites here with us. Professor Ellen Judd is in, I think, Winnipeg. She's a Pugwashite and an emeritus professor of anthropology, University of Manitoba. And in Laval, Quebec is Michel Duguay, who is, he tells me, recently retired and emeritus professor of engineering at Laval University. We have also two other members of the Pugwash group, and they're all going to really keep you guys on your toes. Peter Meinke is someplace near Ottawa, and another Ottawa man, I don't know whether you guys have met each other yet. If you haven't, this is a good chance, is Paul Beckwith, who is my most esteemed climatologist. Paul runs a talk show that has me beaten hands down. He has not a talk show. He has a video where he explains climatology to the world. We need to talk about two different kinds of rock dust. The kind that you smash by pounding rocks, and the kind that you dig out of the ground when you're trying to get something else. That is, there's a lot of mine tailings in this world, and you can use the rock dust or the rocks that you've pulled out of the soil to make your hole in the ground and mine stuff. You can use that for the application of rock dust for the purposes I've just talked about. So Greg Dipple is precisely the man to talk about with respect to mine tailings. So here we have two people who each have their own approach to the production and use of rock dust. Tom Vanagore, who's a quarry man, and Greg Dipple, who's going to try to convince us that we should use rocks out of mines.
Well, first of all, the rock powders, that the pulverized rock powders that we direct into agriculture are also a form of byproduct from commodity aggregate production. They may not be tailings from mining for concentrates, but they are potentially commodity byproduct. So that's a distinction where the lines sort of blur from hard rock that's quarried for the purposes of agriculture and tailings or the use of byproducts. So we actually do both. The quarry that's behind me is actually a carbonate quarry where the commodity is carbonate lime, but we found a type of black shale in the quarry that's very useful for agriculture. So we've actually directing that material into ag, whereas before it was just a byproduct and something that was problematic for the quarrymen. So in the same way that we use these undersized or pulverized rocks from commodity aggregate, you can do the same thing with certain mine tailings that are derived from iron ore or other types of ore concentrates with care. And I think Michelle or Michael would be useful in discussing those parameters. So that's one distinction I wanted to make. The lines are blurred there, but one of the advantages of going after the byproduct is because the cost effectiveness of using previously quarried or mined product is extraordinary when it comes to the benefit of using all the energy that has already been applied for extraction of commodity rocks and directing that byproduct into agriculture. In other words, you've already done most of the work there. So that's a great benefit. And
okay, what are most of the rocks used for that, beforehand, before you were using it, the powder, what do most of the people want to buy the rocks to use in their gardens or to use for construction, making cement, or what?
Well, a lot of the alkaline elements, the alkaline silicates that you were mentioning that are used to capture carbon for enhanced weathering, those are often commodity production. Those are hard rock that are directed into construction aggregates or other construction materials. So there's just large quantities of those materials that are historic. There's also the same types of tailings from the historic or legacy production of iron ore and copper and some other metals or semi-precious metals. And those materials also have a great amount of use. So those are the types of things that have generated a lot of materials over the years.
Okay, now I want Greg to tell us about mine tailings, and then I would like to shift the gears a little bit and have Peter Van Straten talk particularly about the work that he's done, I think largely in Africa, encouraging the use of rock dust for farming. But Greg, what's the story with the mine tailings?
Sure, happy to talk a little bit about the work we've done. So I've been working on using waste streams from mining, in particular tailings, which are the really finely ground material that comes at the tail end of the mineral processing circuit, and using that through essentially weathering reactions, like Thomas has referenced, to capture carbon dioxide directly from air and precipitate carbonate minerals, which are a durable form of carbon storage. The vast majority of our work actually works within the mining footprint and uses the existing waste facilities. We're not necessarily advocating spreading all mine tailings out in agricultural land and in forests, because there's a number of issues there. But maybe to frame the discussion, I'll make a couple comments about that technology approach. So one is, enhanced weathering is a viable solution potentially to sequester billions of tons of CO2 per year. To put that in context, of course, we need to be removing CO2 from the atmosphere at the scale of about 10 gigatons per year sometime in the second half of this century. So this is a fundamental problem we face as a society, and there's a number of groups working on the role that enhanced weathering might play in that process. There are a few really important considerations. One is there a net carbon benefit? Another is, are there other side effects, as you mentioned? And in particular, looking at mine tailings, of particular importance is the other metals that are carried in those materials. And that is just like there's a huge variability in the rocks on Earth, there's a huge variability within mine tailings. And many types of mine tailings, in my opinion, are probably very poor candidates to spread on agricultural land because they would cause pollution and release elements or metals that we know can be toxic to life. So and there's regulations in places like EU that limit the toxic metal capacity of any amendment to soil on agricultural land that will govern the application of these things. So we have to be very careful. So a lot of the tailings that I work in are ultramafic rocks. They're magnesium silicate rich rocks. They tend to host things like platinum and chrome and nickel. Some of those metals are critically important to the deployment of renewable energy. If we want to drive electric cars, we're going to have to increase the scale of nickel mining globally between 10 and 20 fold in the next 50 years. Because we've never mined enough nickel in the history of our civilization to supply the battery market that we'll need if we're going to drive electric cars. So but those tailings would be very likely very poor candidates to sprout on agricultural land because they contain a lot of chrome and other elements, chromium, that we know can be toxic to life. So we have to be very careful on how we go about doing this. Mm-hmm. A couple other high-level comments is the application of mineral dust has clear benefits for the productivity of agricultural land, and I'm sure there's other people on this call that know a lot more about that, and we'll chime in as well. But as a scientific community, we're just starting to understand the carbon benefit. And it's, as one can imagine, it's highly variable. In arid climates, it doesn't seem to work that well based on papers that have come out just in the last year. When we start to look at greenhouse gases beyond carbon dioxide, especially the nitrogen cycle and the production of methane, which both produce other very strong greenhouse gases, there can be negative effects associated with the application of mineral dust that might negate some of the positive effect associated with enhanced weathering. So there's in the last 5 years, the number of people working on enhanced weathering has multiplied probably 100-fold or more. And all of this activity is teaching us a lot more about the complexity of the situation. That's a good thing because there are some clear opportunities here, but there's no simple, easy, widespread one solution to solve the problem. This is a complex problem. It's going to take real work to figure out the best way to deploy it, but I have no doubt that it will play an important role in helping to mitigate climate change, especially when you combine it with the applications of things like biochar, which seem to really enhance the rate of carbon capture when we apply mineral dusts.
Our proposal actually includes the notion of applying not only rock dust, but biochar and a biostimulant made from kelp. Seaweed apparently is a wonderful resource to capture CO2. And the thing is that, of course, the first thing it does is rot and goes right back into the air. So you need to find some source that you could convert it into something useful. And this biostimulant would be a wonderful addition. And also the thing about the biochar is that everything sticks to it. So it would hang on to things and keep the biostimulant and some of the other minerals in the rock dust from immediately going back into the atmosphere. It'll keep it in the soil longer. So I think the combination is one that we hope that we'll find some way of blending or mixing or using these things together. Thank you. Okay, now I'm going to ask all of the Pugwashites to feel very free to just jump in as soon as Peter Van Straten has told us what he has been doing in Africa. I think you're doing it mostly in Africa in the past, weren't you? Tell us about your work with rock dust, sir.
Hello, everybody. I am a geologist, and I'm a geologist turned agrogeologist. I worked as a typical geologist in mineral exploration. I worked for the UN in Africa. And at some point, I thought, what are we geologists contributing to society apart from providing raw materials to our daily life? So I was thinking of changing my career completely, and I looked at materials that can benefit agriculture. So I became an agrogeologist. And so we started out with projects in Tanzania, in Zimbabwe. I worked in Sri Lanka, in Indonesia, and so on. But at the very beginning, we were looking mainly at replacing imported fertilizers. So looking at phosphates, locally available resources for smallholder farmers, not for the big guys, but for the smallholder farmers. And that's a challenge. And we have tons of experience with this. when coming to Canada at the University of Guelph, I was lucky to teach this practical experiences. We had IDRC support. I wrote 2 books on rocks for crops. And I'm teaching these subjects in many countries. Lately, in the last 10 years before COVID, in Brazil and in Uganda and Indonesia. So
you're still traveling to other countries to teach people how to use this stuff, right?
Sure. This is I'm retired, so I have lots of, I'm not tired. I'm retired, but not yet tired. I try to bring my knowledge across to other people. And that's what we need. It's participatory approaches, not some white guys coming down there with some solutions. It needs a collaboration. And this is one of the problems we are having, is that we are coming from the geology side and the soil scientists and the agronomy side. They are not linked together as yet. It was hard to even get a course on agrogeology going. So bridging disciplines is a major problem. But the most important problem is, I think, is to convince farmers to use this. And so we have made lots of little projects, nothing big, but small projects with farmers and NGOs and local universities to do this. Coming to the word rock dust, I am a little bit, I don't like dust, actually. Yeah. We have to be more specific. We have to, if we want to make this agrogeology rocks for crops approach a success, we have to understand to use the right rocks. So, for instance, basalts, phonolites, basanites, wollastonite, and on the right soils, in the right climate, and for the right crops. And we made little mistakes, many mistakes because we did not understand the systems. And finally, we have to understand the economics of it. So we have to make, from the onset, we have to make some life cycle assessments that we are not producing more CO2 than we are capturing. This is one of the key issues that we have to master. But my focus is people and soil fertilization, and a byproduct is, or co-product would be to capture CO2, which is very
excellent. Well, now, if anybody, I don't want to have you put up your hands. I want you to just feel free to speak as you would as if you were in a, coffee shop together. But I'm sure that some of the Pugwash people have questions to ask some people. So who wants to start this off? Yeah, Michelle.
The first question I would have for Peter is, what are the volumes involved? Worldwide production of CO2 is enormous. Isn't it a couple of orders of magnitude larger than the dust that's produced in mining operations?
Sorry, I didn't catch it properly. I'm
talking about volumes.
Volume.
The volume of CO2 produced.
Yeah. You can calculate that you have 0.3 kg CO2 to 1 kg CO2 per kilogram of rock. Yeah, so it is quite a good number for when you use very much, for instance, basalt. But and basalt is a huge product all over the world. So you have a large potential to capture large contents of CO2 by applying them to soils.
So you're saying that the order of magnitude is correct.
Yes, it is. Yeah, it is. It's huge.
I think I want to introduce David Demare, another person who's a specialist on rock dust farming, or you don't like that word, we'll call it something else, but agriculture using the application of rocks. And you're in Springfield, or in the vicinity of Springfield, Massachusetts.
Peter, Professor Van Straten, I consider he's a sort of a grandfather of this whole thing, going back years and years, and mentored a number of people that are in this space, some of which are no longer with us, unfortunately. But I might say that there is a distinction between applying large volumes of the alkaline silicates, whether it's for enhanced rock weathering or mineralization for direct air capture or onto land, and using rock minerals for fertilizer and enhanced crop production. I mean, the professor was the first one to coin farming with rocks and minerals, and growing crops with rocks. The whole idea that you're using minerals to grow food or productive agriculture is at the foundation of using minerals to grow crops. And it turns out that some of these minerals can capture carbon through mineralization. The academics have seized on this particular feature for enhanced rock weathering. But in fact, most of the academics that are in this space have very little experience using materials to actually grow crops. And so now there is a divergence between what is being proposed in the models and what is actually beneficial and necessary when it comes to growing crops with rocks and minerals. So these are two distinct things now. Mm-hmm. And without even getting into the use of mine tailings for engineered solution, as Michelle was speaking about. So I think we have to keep those ideas somewhat separate. And what we've been proposing, Rock Dust Local and some of our other the people that are working with us on using rocks for fertilizer is trying to integrate both the carbon capture potential, greenhouse gas management potential directly into a practical use of using rocks and minerals to grow plants, etc. So that's where I think that the Pugwash group could actually probably get some traction, where we're actually integrating these materials directly with agricultural production, mm-hmm. and taking advantage of some of the carbon capture potential, greenhouse gas emissions reduction potential, but doing it through use of fertilizers. And the professor has a tremendous amount of experience on how to do this, and we've been sort of using these techniques to build relationship with farmers to make these materials readily available to others.
Peter, you mentioned that you have to be careful. In fact, everybody's already made it clear that there are ways in which you could do damage by using stuff wrong. And I want to mention a woman named Mary Yap. A couple of times ago, I had a guy named Noah Planovsky on the show, along with David Bierling, who sort of did the research on a lot of this carbon capture aspect of things. But Mary Yap is in business with Noah Planovsky, and she runs this organization that actually goes out and helps farmers. But I watched a show that she did a while recently on a different venue, and she emphasized more than anything else that you really have to test all the time, and not so much all the time as in many different places. She seemed to emphasize that, if you put the kind of minerals down, you can do a lot of damage, and the amount that you need and the quality of the stuff that you want has to vary considerably with the nature of the soil. So you have to test it. and you have to test it a lot, because she says if you test one field, just a few feet away or a few meters away, you'll find somebody a patch of soil where the content of the soil is quite different, remarkably different. So I'm wondering whether my immediate thought was, this gets very expensive. I don't know what it costs to test the soil, but how often do you have to test it, or should you? And is it possible that one of the incentives that the government could offer farmers, let's say Canadian farmers, to adopt this technology, one of the incentives would be to give the testing free of charge to them whenever as much testing as they think they need. Tell me about how much testing is required, and what are the practicalities of deciding on whether to spend the money for that.
So testing soils is a routine thing. It does not cost very much. I don't want to give numbers, but $30 a sample or less would be sufficient. And we have to be careful with on which soils to apply these materials. So one has not only to analyze the typical elements, nitrogen, phosphorus, and potassium, but also micronutrients and the pH. And I will give you an example. We did some work with rock dust, basaltic rock dust, and we applied it on the wrong soil and with the high pH, like the material itself, it has a high pH, and the results were negative. So we have to understand the soil on which to apply it. And then we have to understand which crop to apply it to. So we did some work in Uganda, and we did work with phosphorus and on bananas, and the bananas did not react to it because bananas require potassium. So we have to kind of match, tailor the rocks, the suitable rocks available close to the farming areas, to the soils, and to the crops that the farmers need. So it's a bit of a balancing act, whereby you have to understand these systems. And of course, you have to do it in the right climate too. So in Canada, we are unfortunately having long winters. And so the best climates for this rock applications is certainly warm and wet in the tropics. But there are exceptions, and we have to be very careful in choosing the right place. But I can see for the Canadian context something what David Beerling said in your podcast here, to apply it to replace rock dust for liming material in forests. Rock dust, particularly basaltic rock dust, have a liming effect. And if we are using it, as Tom said, from mine tailings or existing quarries, then that would be certainly a method to use these materials here in our environment. But we have to use it only where we are using liming material at present. Most of the Canadian situation, at least here here in southern Ontario, the soils have a pH of 7.5, and they are not devoid of these elements, nutrient elements. So it might not be the most suitable thing to apply here. So we have to really focus, where does it make sense, and on which soils, on which crops, and in which climate. And it has to be economic. That's something which we have learned over time. We have not, we might have good ideas, But if you have to transport these rock dust over 100 kilometers or so, then there you produce more CO2 than you can capture.
Mhm.
So one has to differentiate, yeah.
Okay. Yeah, okay, that it worries some, because it sounds as if the farmer has to be a brilliant scientist in order to know what to do.
Well,
That's just,
not necessarily. I think that, as Peter was saying, soil testing is standard practice
yes.
on most commercial operators, and whether they're smallholders, fruit and vegetable farmers on 5 acres or less, or whether they're large,
Mhm.
hundreds and hundreds of acres.
Yep.
Soil testing, routine soil testing is standard. So the question then becomes, how do you adopt these sorts of rock minerals into a program, an existing management program, in an economic framework? And that's a question that we've been answering for about 20 years. In other words, this is not rocket science. One of the beauties of adopting these materials is it's fairly simple and straightforward once you have your basic analysis of the different resources and soil tests and a management strategy in place. This is readily available, which is why enhanced rock weathering is being seen as sort of a silver bullet, which I think is mistaken by the academics, because they fail to provide for a complete integrated model. Now, one of the things we're doing in Canada right now is we've been experimenting and actually been deploying these materials with synthetic fertilizers as mineral fillers. Otherwise, to create an NPK, nitrogen, and potassium, phosphorus, to create these sort of fertilizer compounds, oftentimes fillers are applied and they just use carbonate rock or any sort of a dumb mineral. Well, these smart minerals can be put into the fillers, and they as a filler, and they actually provide agronomic benefit. They provide mitigation to acidification of the use of salt, synthetic fertilizer salts, and they tend to also render the materials advantageous over a longer period of time. So there are ways to integrate these materials even into commercial conventional farming in Canada, which is something that's already being done. So I think there are ways to actually do this, and it shouldn't be a scary thing.
I want to ask whether or not the Canadian government is already very proactive in trying to not only find out what the questions are that need to be answered, but also expedite the development of this kind of technology. Are they on top of this? Are they moving fast enough? Is there any point in trying to encourage a more concentrated effort to bring together the kinds of concerns that Greg has mentioned, along with what basically Peter has mentioned?
I don't know well enough what the Canadian government is doing here in Canada. I only can give positive remarks to what Canada is doing abroad. That what we have been doing in Tanzania and in East Africa through IDRC, the International Development Research Center. Mm-hmm. So there we had a wonderful support, and this is still continuing. What we do here in Canada in terms of agro-mineral research, I don't think it is very much. I think it's more along the line what Greg Dippel is doing, looking at tailings and materials that are potential co-products, but not necessarily for agriculture. And as Greg pointed out quite correctly, it's, for instance, nickel and chromium and these things. Many of these things cannot be used and should not be used, while others can be used. For instance, I have been working on tailings myself in Zimbabwe on a carbonatite project, and we found wonderful finds, and we could use them in a local environment for local farmers. So we have to understand these tailings, and I think that's where we have a really great advantage through our technology and academia.
I might jump in with a couple comments relevant to your question and related to the previous discussion. I think this idea of testing for the impact of the application of minerals to soils is a lot more complicated when you get into the carbon space. It affects multiple greenhouse gases, as we referred to earlier. It also evolves over years. And so testing in the first year to look at the greenhouse gas impact, the application of the mineral material might behave very differently after 2 or 3 years, because the fast reacting parts of the rock will be exhausted and the material will behave differently. So testing for greenhouse gas mitigation impact is, I think, a lot more complicated and is going to take a lot more work to figure out properly. But that doesn't mean that we shouldn't be deploying them if they provide other benefits. And if it turns out we find out that their greenhouse gas benefit is as good as we hope or better than we hope, then that will obviously be helping us as we're trying to mitigate this very significant problem. I did want to mention a little bit on scale, because I mentioned briefly there, it takes a long time for these materials to react, and how they react evolves over time. There have been studies looking at the scale at which you can produce things. So we, as a society, we produce, a couple of gigatons a year of alkaline industrial waste that would include mine tailings, which is the kind of thing that some of that could be used to as amendments to soils and forests. But if you look at the modeling, at least, you need probably, to do a gigaton of CO2, you probably need to apply 10 gigatons of mineral dust. So if this is going to be a gigaton solution, we're going to be mining a lot of rock that we're not currently mining. I think that's a cold, hard reality that's going to be very hard for us to avoid. So we as a society have to decide if we want to how we do that, or if we want to do that and how that's done well. The last thing I would mention, because I think Michelle and others probably want to jump in terms of government incentives, there's a couple of recent examples where the federal government released critical minerals strategy just last week, actually announced here in Vancouver. And also Ontario has a critical minerals innovation fund. So the government is seeing that we need to, we have this opportunity for Canada to contribute towards the development of critical minerals, which we need for deployment of renewable electricity. And there's a whole bunch of incentives that have been rolled out. Some of that takes the form of funding R&D. Some of it takes the form of tax credits. One can imagine those are great instruments, especially if you have ongoing operations, whether it's in the space of agriculture or if you're producing material like in quarrying, or I'm aware of companies that make the gravel for roof shingles. They produce large amounts of very fine mineral material, which could be used as agricultural amendments. So there's a lot of waste streams that might be out there associated with industrial activity. We don't have a roadmap of that as a country or as a society. We need to understand those opportunities better and to Peter's point, find the right applications and where they work. And our provincial and federal governments have been finding ways to provide incentives for other related issues like the development of critical metals. I would argue that those kinds of incentives could be helpful here as well.
The tailings is certainly a problem, but they can also create co-products. And we have to make a kind of an inventory. And that's what we have been doing in Brazil. We have been just going from one quarry to the other and see what people are throwing away and whether we cannot make use of them so that they are not wastes, but they are co-products. And there's a whole wonderful world out there which we have not even touched. We have to make an inventory of our so-called wastes. And then we can develop some strategies to make use of at least some parts of this, that waste is not a waste.
So just to say that our company, Rock Dust Local, the local part resulted from an inventory, which I did and people that were helping me to do so, conducted over a period of about 20 years, mostly in the States, but also in Canada, working with fellows like Klaus Bond, who's unfortunately passed away recently, was a pioneer in this idea. And Klaus and I work together across the border. You've also have John Slack, who developed one of the carbonatite resources in Canada. So this sort of work that the professor is talking about, the inventory, we've been doing this now for a quarter century. And we focused on materials that were United States Department of Agriculture, National Organic Program compliant. In other words, in terms of the types of materials, what they had been subjected to in process, and then taking a good look at mineralogy and chemistry to make sure that we weren't land applying heavy concentrates of any particular toxic material or metals or so forth and so on. So this could be done more comprehensively in Canada.
Is there such a thing as a map for these things? I myself have been just curious, where are the mine tailings? And I couldn't find a map showing that where in Canada there are piles of mine tailings. I couldn't find, what I wanted to look at the moment was, is there any correlation between where the mines are and where the agriculture is going on that could actually use this stuff? And I think it'd be nice to have some maps that show the proximity of these resources to each other, so that you can, especially since the cost of transportation is such a huge factor in determining the profitability of applying these things. So are there any such maps?
Well, the short answer is no, because it's not like the yellow pages that people were looking for, commodity tailings to, put in their yard. So no such maps exist, although the resources of late do exist so that you could create maps, and some people are working hard at doing that. But the short answer is no, there aren't, and that's why it's taken so long. Now with the internet, it's easier, but 20 years ago, you couldn't just bring up a database that's out there. But these things are not unknowable.
Okay, Greg, is it possible that we could try to urge the Canadian government to do more to integrate these two concerns, so that people working on mine tailings have some contact or work on a team with people who are trying to see how to apply this in particular specific agricultural locations?
Yeah, I would throw in a couple of comments. Tom's right. It's not readily available, but it is knowable. Some examples. There's a recent paper where people were essentially using Google Earth and artificial intelligence to map out all the tailings deposits of the world based on looking at pattern recognition on what you can find from existing remote sensing data. Those kinds of approaches can help. I know that under some critical metals programs within the Canadian government, that Natural Resources Canada is funding internal research to get samples of and document mine tailings from across Canada, more specifically around battery metals and critical metals, but that could easily be expanded. And that includes getting samples and analyzing them to start to put together an inventory. And the intent there is for this inventory to be publicly available on a web resource. Ultimately, those kinds of activities could be expanded for this use, almost certainly. And lastly, to go back to these kinds of strategies like the critical metals strategic plan, that these plans that are happening both provincially and territorially and federally, providing incentives to commercial operators and to industry to provide these data, potentially for their own net benefit in the end, could really help resource this from the ground up. Let the operators give the operators some incentive and resources to contribute towards the development of a database that can bring these materials, bring this information together.
Who else has questions?
Just to Greg, of course, right now we are doing it for critical metals and for nickel, cobalt, and so on. But we should be also including materials, potential co-products for agriculture. And maybe it's not as urgent in Canada, but worldwide, we have lots of resources that are piling up and are not being used and are actually problems rather than contributing something to grow crops. Yeah.
No, I fully agree, Peter. And that's my intent, is that we have examples of initiatives that have been launched and they could be expanded to help tackle this problem. Absolutely. I completely agree.
Michelle.
Good.
Well, the question I have is this. Is it possible to is it possible to envisage a long-term policy where we would reverse the policy that is being applied now in the Amazon basin region? In other words, with your rock dust and progress in genetics, is it possible that crop yields could be doubled over the next 2 decades or so? This would liberate land for more fast-growing trees. Trees are really good at sequestering carbon.
The Amazon is, of course, a big concern and a problem, but to bring more agriculture into the Amazon would not be a very good idea, because the agriculture for growing soya beans or something like this will destroy the Amazon. So we have to think maybe we can use some of the material there for enhancing tree growth, but not for agriculture. Brazil is a huge country, and they could have, particularly in the south, they have huge resources of agrominerals that they can be using to enhance crop production or even forestry, but not in the Amazon.
I think it does bring up a good point, though, in that now we're talking about management, agricultural management or land management. So in this time where we have large changes and drastic changes, chaotic changes to the temperate zone, it does make sense that agricultural practices will also need to be responsive to those changes, which is why large-scale, broad-acre, perennial plants may not be, or annual plants may not be the best thing, the best strategy. So integrating more permaculture or more forestry to large-scale farming and using rocks and minerals to establish as a one-time or repeated application in the management, establishing new trees or shrubs or types of crops that could be used on a permanent basis. This is something that both Canada and the US, as well as other developing countries, could use local resources combined with management to respond to climate chaos. And that is an extremely important part of any climate solution. You can't apply a solution to a framework that is no longer relevant, a farming method that is going to essentially go away because of the shift in the temperate zone. So yes, minerals on one hand, but management on the other. It's a combination of those things that are going to be extremely critical to the survival of civilization. Now, if you believe the climate,
I like your pointing because you're mentioning the time element. My concern is that, we are facing emergency. The climate is an emergency and we need to speed it up. And so what we were looking for the Pugwash project was things that could be done, that could get going and really started well within 5 years if Canada decided to do it. Now, I've been hearing, everywhere concerns about, is it safe, and all these different things that might go wrong. And my question then is, what is the most efficient way of quickly handling the worst of our concerns and trying to get something going? If we had the Canadian government completely engaged with trying to get rock dust being used effectively, quickly, what would we need to do to bring the agriculturalists and the geologists together, and the government people and the financial backers and whatever? What do we need to do that will expedite this thing, and how long will it actually require before we can reasonably tell the Canadian government, get going? Maybe Greg, you may have the first. Maybe you're closer to government officials on this kind of thing. Can you give us an idea of where things stand now and what needs to be done to speed it up?
Yeah, that's a good question. On the enhanced weathering side, it is more of a grassroots thing within certainly the side that I see, which is the scientific community side. It's sort of been complementing a lot of the stuff that Tom's been talking about. So, we're missing those incentives and those instruments that are being, deployed towards critical metals in the enhanced weathering space more broadly. One of the things that's been talked about that I think was sort of mentioned in some of the previous comments is free testing or lab, a national lab-based testing system where materials could be submitted and tested specifically for the greenhouse gas component. I think that the productivity side of things is better understood, but I think that the greenhouse gas impacts are more complicated and harder to tease out. And so coming up with protocols, methodologies that are accepted, scientifically vetted, and providing the ability to have materials tested at Natural Resources Canada or CanMet or some national lab facility to allow people to figure out where there's value could help to augment an inventory and understand where the good materials are and help assess what their long-term impacts are going to be. But even in there's a private market in carbon dioxide removals, which is very active. It's spurring a lot of the new startups that are coming out. You referred to Noah's company, for example. There's tons of new startups. I have one of my own on using mine tailings. We partner with mining companies, and these private removal markets are huge, right? Just last week, Frontier announced their purchases. They're repurchasing in increments of $500,000 for carbon dioxide removals. And those systems right now, they don't even have uniformly agreed to methodologies to actually accounting for the carbon dioxide removal. There's one accounting, the first methodology for counting CO2 removals for enhanced weathering was announced just in the last 2 weeks by Puro, one of the private market companies that tries to validate these things. And it's still quite early days and quite frankly, quite controversial. So even within the private markets and the scientific community, we don't have established methodologies or mechanisms or ways of doing the accounting on the carbon side of things. So there's a lot of work to be done there. But I guess one of my points is we know it. Although we don't know how good the impact will be, we know that it can have a positive impact, and we have these other motivations for doing it. So if we can get going on it on the basis of productivity, soil productivity, and enhancing agricultural output, and focus the economics on that side of things, then we can start to generate the data that we need to understand what the impact will be from a greenhouse gas standpoint. We're not going to have the answers as scientists in a year or two. That doesn't mean we shouldn't get going, because we have these other motivations, including reducing waste streams.
In previous shows, there have been suggestions that we could incentivize farmers to start applying rock dust right now by, giving them a certain amount of per acre payment of some kind. But now the question is that a dangerous thing to do, or can we do it within 5 years? Can we get the state of information or knowledge about the risks and the benefits down pat so that within 5 years it's a reasonable thing for the government to actually undertake that kind of encouragement for farmers?
Well, the science has been going on in this sphere, specifically for enhanced rock weathering, but even before that for a number of years. So the question of whether there's toxic metals or what happens to the plants and things of this nature, a lot of this is very well studied already. I mean, even in the United States, there's 5 or 6 years continuous of crop heavy applications of basalt, as an example, and everything from plant nutrient uptake to seed concentrations. And so these things have been fairly well modeled, and the safety and efficacy of these materials, if they're applied correctly, and if the parent material is well known, which it is through normal and accepted testing practices, the ability to go out with 100% confidence is there. I mean,
It's already okay. Well, our time is up, but I want to make sure that Greg and Peter agree with you that you could right now start incentivizing farmers to do this, but you have to tell them pretty carefully what to watch out for. Is that a fair thing, Greg and Peter?
Yes, I agree with Tom on the increased productivity side. We don't understand the greenhouse gas impact of these applications. And if we're going to start doing it at a much larger scale, especially if we're extracting new materials to do it, there will be greenhouse gas productions associated with it. So I think we need to be careful with that. We know that there are clear protocols in which, the framework in which to apply it to the soils. I'm not an expert in that space, but from what I know, I completely agree with Tom. I know the EU has very strict rules on the metal content of agricultural amendments. So there's legislation in place to help govern these kinds of things. But the uncertainty is around the long-term climate impact in terms of greenhouse gases. And that is very much an open question in the scientific realm. So we don't want to generate a whole bunch of new greenhouse gas emissions to apply these materials without expecting that they're going to produce a net positive. We want to do it in a way that minimizes the greenhouse gas impact, so that if the greenhouse impact ends up being small, which it could be, we haven't made that problem worse.
Thank you. Okay, Peter Stratton, you have the last word.
Yeah, I come back to my first comments there, that we have to be careful when applying the different rock dusts to soils, that we have to analyze the rocks properly. That's not a big problem. We have to understand the soils properly, which is not a problem. But are our rocks tailored towards these particular soils? That is absolutely not clear as yet. And particular to crops, which crops to apply it to is also not. It's still in lots of experiments are being carried out there, but we are not there as yet. And to come to Greg's comment, to prove that we are removing CO2 is not so simple. Yeah, we have to do trials with water sampling and mass balances. We are not there as yet. I can give you some examples from Australia, where I was just pre-COVID, where we have wonderful rocks, basaltic rocks. We have acid soils. We have a wonderful wet climate in Queensland. And they understand which crops to apply it to. I think there we have some examples to understand the system. And lastly, we have to understand that this is also a matter of economics. And
Thank you all. This has been so interesting. And instead of settling matters, you just opened up a whole bunch more. I hadn't even heard about the problem of creating more greenhouse gases. So now I'll have something to keep me awake at night. Thank you, all of you. It's been fun and very helpful. So, and Merry Christmas to you all. Okay.
Oh yeah,
Christmas to you.
Bye.
Thank you. Nice to meet you all.
Project Save the World produces these shows, and this is episode 535. You can watch or listen to them as audio podcasts on the website tosavetheworld.ca. You can share information there also about 6 global issues. To find a particular talk show, enter its title or episode number in the search bar, or the name of one of the guest speakers. Project Save the World also produces a quarterly online publication, Peace Magazine. You can subscribe for $20 Canadian per year. Just go to pressreader.com on your browser. Into the search bar, enter the word peace. You'll see buttons to click to subscribe.